I'm going to do examples 2 and 3 together now. So let's get started. So we're going to start right here with example 2. So the amount of force exerted on a rubber band impacts the distance it is stretched. The function d equals 5f, I'm just going to write that down here, d equals 5f, can be used to determine the distance d for a force f pounds. Determine a reasonable domain and range if the maximum force you can exert on the rubber band is 35 pounds. Okay, so let's think about it. Basically, what's force? It's the amount that you're working on something. So think about it as the harder you pull, the farther that rubber band's going to launch. So if you're trying to hit someone across the room, you got to pull harder than if you're trying to hit the person next to you with the rubber band, right? Okay, so first things first, we have to identify the independent variable and the dependent variable. So if I'm thinking I have to pull back the rubber band with force in order to get it to go anywhere. So that means that my independent variable is that force F, because I have to pull it back to make it move. The dependent variable is going to be the distance d, because it depends on how hard I pull. Again, if we're trying to cheat, your independent variable force is always going to be that number behind the F. Your independent variable is always going to be behind that number on the side. Your dependent variable is always going to be by itself over there. I'm just throwing that out there. But logically, your independent variable is always the one that you have to change in order to make something happen. Okay, so if I'm thinking about my independent variable, which is force, I have to decide if it's continuous or discrete. So can I have like 1 force, 2 force, 3 force, like discrete things? Or can there be different variations or like little changes in how hard I pull? And I know that if I'm pulling that rubber band back, it's going to be continuous, because it's not like I can measure how hard I'm pulling in terms of like a countable number, like 1, 2, 3, 4, 5. It's going to be continuous because I can pull it back to varying degrees of depth. So now I need to think about my restrictions on domain and range. So again, I'm going to rewrite my equation. I know that d equals 5f. And I know that my domain always goes with my independent variable x. So domain is always going to go with my independent variable. I'm going to write it like this and get it set up. My range always goes with y, which is my dependent variable. So I'm going to set this up like this too, just so I know it's coming. I rewrote that down there. Okay, so determine a reasonable domain and range if the maximum force you can exert on a rubber band is 35. So the max force that I can exert on a rubber band is 35 pounds. Okay, so that means I need to decide force. Is that with my x or with my y? So I go to check at the top. My independent variable goes with my x. It tells me right here. My dependent variable goes with y. Well, I already know that my independent variable is force because I found it first. So this tells me that my maximum force or my maximum x value is going to be 35. So I know that over here, for my highest x value in my domain, I can fill in 35. I also know that that value is going to be included. So I'm going to draw in that little arrow underneath, or the little line underneath the arrow, so I know that 35 is included. For my lowest value of domain, I know that if I don't pull on the rubber band at all, so I exert 0 force, it's not going to go anywhere, but it'll still work. So I know that my domain is going to go from 0, meaning I don't pull on that rubber band at all, to 35, which is the maximum amount of force I can pull on that rubber band. Let's think about the range. So if I don't pull my rubber band at all, that means it's going to go nowhere. So in the same way, I'm going to keep this 0 here. My 0, my lowest value, is going to correspond to a 0 distance pulled. So we can kind of think of it like this. If we're thinking about our range as like this is the lowest side and this is the highest side, then my range, the lows have to go together and the highs have to go together. So these numbers on the left go together and these numbers on the right also go together. So this high value is going to go with this high value over here. So I need to figure out, if I pull my rubber band back with a force of 35 pounds, how far is it going to go? So how far is it going to go? How can I figure that out? Well, I know that my distance is equal to 5 times the force. So if I take 5 times 35, so if my distance equals 5 times F, I know that my F up here is 35. My distance is going to be 5 times 35, and I know that 5 times 35 is 185. You guys are probably going to have to check that. I'm going to do it on my phone calculator. 5 times 35 is 175. So I know that the maximum distance I can pull it back is 170, or it will go after I pull it back with a maximum force of 35 pounds is 175. And I also know I should have added in these because they can all equal each other. Again, it's really tricky, so feel free to pause and go back. But we are going to think about it like this for the rest of the time. I'm going to do one more example before I let you guys practice on your own for the rest of class. So bear with me. And again, if you're getting confused, please, please, please ask a question. So last one. John's looking for something to do on a Saturday night. He finds that tickets to a concert cost $20 each. So that seems important. The function y equals 20x represents how much he will spend on x tickets. So remember, it tells me that x goes with tickets. He can't spend more than $180, and we're looking for the reasonable domain and range. Okay, so I know that my independent variable always goes with x, and my dependent variable always goes with y. My independent variable is x. It literally tells me right here, x means tickets. So that one's pretty easy. My dependent variable tells me goes with y. Unfortunately, it doesn't tell me what y means, but I do know that I'm trying to buy tickets and that my dependent variable can be cost. So independent variable is tickets because the number of tickets tells me how much I'm going to end up paying. So let's think about if it's continuous or discrete. So tickets, does a half ticket have any value? Do I want to buy half tickets? No, I don't, right? I want to get one whole ticket. So I know that's going to be discrete. And now I'm going to think about domain and range. So I know that my domain is going to be my x values. Range is going to be my y values. I want to know what the lowest possible amount I can pay is and the highest. Okay. So if I buy 0 tickets, and domain, remember, is tickets, range is going to be the cost. I forgot there for a second. So I'm looking at domain, and then I'm also looking at range. Okay. So domain. If I buy 0 tickets, how much am I going to pay? So if I decide not to buy any tickets, how much am I going to pay? I'm going to pay $0. Okay. Now this is where I need to go back to the problem. It tells me he can't spend more than $180. So the maximum I can pay is $180. Well, how many tickets can I buy for $180? I can solve this 2 ways. I think the easiest way is, so I have $180. How do I figure out how many I can buy if they cost 20 each? I divide. So I'm going to divide that 180 by 20. That'll give me 9. So I know that the highest number of tickets I can buy is 9. And remember, this is like a real world thing. So that's where if you guys would send me some real world examples and we think of a budget constraint, we can see how many of those things would we, or how many of each thing would we buy to give me that max amount. So if I have $180, I know they cost $20 each. I'm trying to figure out how many friends I can bring with me to this concert. I can only bring 9 if I'm paying for all of them, which please don't do that ever. But, you know, some days it happens. Okay, so this is where I leave you for today. Your answer key is going to be at the front of the room. Please make sure to ask any questions. We have some STAR questions back here. The STAR test loves these type of questions. So please make sure you're asking if you're confused, and we will see where to go. Thank you.